Hello, everyone. My name is Daniel Villarreal, and I'm from California State University, Long Beach, and this is External Interference on Autonomous Robotic Swarm with Jaquan Ishmon, Trevor Smith, Michael Butts, Dr. Yu, and Dr. Gu. The motivation behind the study is to look at defense applications for swarm robotics. This study used a state machine, which I'll explain in a minute, to allow the individual agents to make their own decisions depending on the aspects of that state. We also use flow fields, which were used for its ability to solve for a solution at any point in continuous space, among other things. And a doublet flow was used also for its effectiveness in one-directional movement and the recycling of agents. That recycling of agents becomes very important when we vary the number of agents within the scenarios. So the state machine, the aspects of the state machine are as follows. We can see that the factors that affect it are battery life, the distance from home, and the distance from the invader. So these are values that are calculated by each individual agent after every loop in the simulation. So once the invader is actually detected, the agents can perform a doublet flow. They can utilize the flow fields to return home or continue with prior tasks. And we'll get into what the doublet flow is and flow fields are over here so that we have enough time to get into the results. So essentially what the doublet is this circular motion along each side of the invader that allows it to push the invader in one direction, that direction hopefully being away from its target, being home, which we also call the defensive waypoint or the sink. A sink, that term is used since the defenders will all fall into the general location of the home if they so choose to protect it and guard it from the invader. And also the source being that they are attracted to but also repelled from the invader, but they have this circular motion known as a doublet, which is very interesting and we'll be able to see in action when we get to the results. So when we look at the results here, we can see that in these different figures that I'm showing, so some are moving here. We vary the amount of defenders, which can be shown in green, and the invader in red. So what happened was some defenders decided to actually head home and follow these streamlines. So the streamlines are just paths that the defenders can choose to follow to head in the direction that they want to go, either home or the invader. And some would follow it to home to protect it, as can be seen here. And some would actually follow it to confront the invader and get it out of the area. As we increase the amount of defenders, we can see more and more that some would actually choose to confront it. Once we got to 19 defenders, 20 agents in total, but 19 defenders, we saw that 3 defenders headed to confront the invader, while 5 headed to protect home, and the rest of the swarm decided to continue its originally assigned foraging tasks. Foraging just meaning search and gather tasks that the operator decided to assign the swarm as a whole. So as we can see here, this right here where my laser pointer is, that is the doublet actually, this circular movement here. Well, that's what they're trying to accomplish. But their main goal above anything else is to have the invader out of the area. The doublet formation is just an opportunity for them, a different form of defense for them to take up. So as you can see, some of them are attracted to the invader and will decide to follow it as far as it will go. And over here, we noticed this emergent behavior. Emergent meaning that this was not pre-planned in the simulation and just happened. So the interpretation of this result is that the defenders that left decided that the defense response was actually adequate enough that they didn't actually need to be there and could continue on with their tasks. And this was noted in the conclusion as well, where creative defensive formation, distribution defensive tasks, awareness of surroundings, and awareness of current state properties were all observed. If anyone were to choose to continue this work, they would look to experiment with methods used in the study to apply to real-life situations, so using physical robots, or mess with the flow fields and see what the varying strengths would be, positive or negative. The study was funded by the National Science Foundation at West Virginia University. We would also like to thank Dr. Gross and Dr. Pereira from West Virginia University for their help in developing concepts. Thank you.